In this video, we're going to be going over a Calculus 1 final exam on the calculator portion. So question 1 says, to the right is the graph of the rotated ellipse x squared plus xy plus y squared equals 9. Part A wants us to find the y-intercepts of the ellipse. And so our y-intercepts are going to happen here, and those happen when x is equal to 0. So let's work on part A. I have my equation x squared plus xy plus y squared is equal to 9. I'm going to go ahead and replace x with 0. And what ends up happening is these will both become 0, and I am left with y squared is equal to 9. If I were to take the square root of both sides, I would get y is equal to plus or minus 3. Now, if you're in my class, I always want intercepts as ordered pairs, and so the two y-intercepts would be 0, negative 3, and 0, positive 3. In part B, we are asked to find the equation of the tangent line at the ordered pair 3, negative 3. So let's say 3, negative 3 is somewhere here-ish. I don't know exactly where, but we're trying to find the equation of the tangent line. And so I can see here that the equation of the tangent line is going to have a positive slope. So if we don't get a positive slope, that means that we are doing something incorrectly. So I've copied down my original equation. I need to find the derivative, and this equation is an implicit equation because it's not solved explicitly for y. So I'm going to need to use implicit differentiation, but I'm taking the derivative with respect to x on both sides. And on the right-hand side, the derivative of 9 is equal to 0 because that's a constant. And then on the left-hand side, I can split this up into the sum of 3 different derivatives. All right, so the first one, that's going to be the easiest of the 3 because it is just a function of x, so we could use the power rule and get 2x. And in the middle term, I'm going to need to use the product rule because I'm multiplying x times y. All right, so I just essentially expanded out the power rule. And then for the last term, that is not solely a function of x, and so I'm going to have to use chain rule. So what I want to do is I want to take the derivative of this thing with respect to y, and then I'm going to need to multiply that by dy dx. And this, again, is equal to 0. So let's do some more simplification here. All right, so we have 2x plus x times dy dx plus the derivative of x is just 1, so it's going to be plus y plus 2y dy dx is equal to 0. So now what we'd like to do is anything that does not have a dy dx attached to it, I'd like to move it to the other side. So I'm going to go ahead and subtract 2x and subtract y. And then I'm going to be left with these two terms on the left-hand side, and so I can factor out dy dx from both of those, and that will leave me with x plus 2y is equal to negative 2x minus y. And finally, I can divide x plus 2y on both sides, and if we do that and we isolate dy dx, we get dy dx is equal to negative 2x minus y over x plus 2y. Now, we're not done. That just had us finding the derivative, but we need to find the equation of the tangent line. And we're finding the equation of the tangent line specifically at the ordered pair 3, negative 3, which means in my derivative formula, anywhere I see an x, I want to replace it with 3. And anywhere I see a y, I want to replace it with negative 3. All right, so that's going to be negative 6 plus 3 over 3 minus 6 is negative 3. Okay, and then that's going to give me negative 3 divided by negative 3, which is equal to 1. So that means that the slope of my tangent line is 1, which that matches up with it being positive like I expected. So now I'm going to use point slope form. So my tangent line equation is going to be y minus my y value for my ordered pair was negative 3 is equal to my slope times x minus the x coordinate was 3. And that's going to change into y plus 3. And if I wanted to, I could also change this into slope-intercept form, which if we moved the plus 3, if we subtracted 3, that would be x minus 6. And so here is the equation of our tangent line to our rotated ellipse at the ordered pair 3, negative 3. So this line right here, its equation is y equals x minus 6, which seems reasonable based off looking at the picture. All right, number 2 says consider the function f of x is equal to 2 times cosine of x minus x plus 1. For part A, we would like to find the antiderivative capital F of x if capital F of 0 is equal to 3. So part A, I want to take the antiderivative of 2 times cosine of x. That is going to be 2 times sine of x. And then minus x squared over 2 plus x plus my constant of integration. Now, I know that capital F of 0 is equal to 3. Okay, so all of these terms are going to become 0, so the implication is that my constant of integration is equal to 3. So finally, I have that capital F of x is equal to this function right here. And let's move on to part B. Part B says use Newton's method to find the root of f of x correct to 9 decimal places. To receive credit for this question, you must use Newton's method. You only need to show written work for how you compute x2. Then you can just write the numeric values for x3, x4, x5, and x6. And we're given that we should be starting with the value x1 is equal to 2.1. So that's nice that we're given the initial x value. So let's see what we want to do here. We are told that x1 should equal 2.1. And then x2, using Newton's method, we have the formula for that. And it should be x1 minus f of x1 over f prime of x1. Okay. So what this means is that we will need to find the derivative function. So let's go ahead and evaluate f prime of x here. That's going to be negative 2 sine of x minus 1. So I know my x1 value is 2.1, and then I have f of 2.1 over f prime of 2.1. Okay. So let's come back now and actually let me move down a line. So x2 is equal to 2.1 minus, I'm going to now plug in 2.1 into my original function. So minus 2 times cosine of 2.1 minus 2.1 plus 1 over negative 2 times sine of 2.1 minus 1. Now I can go ahead and throw this thing into my calculator. All right, so I threw that into my calculator and I got this 9-digit or 9 decimal value number, and it says that we just need to kind of show how we compute x2, and from here we can just throw the rest of the x values into our calculator. So I'm just going to go ahead and copy those down really quickly. All right, so notice that it wants us to go up to x6. And the value for x5 and x6 are the first time that this repeats. So if I continue to do this, I should just keep getting the same answer on my calculator because my calculator is only showing up to 9 decimal places. So using Newton's method, this number x6 represents our approximation for the root of our original function f of x, which is equal to 2 times cosine of x minus x plus 1. Question 3 says use the limit definition of a derivative to find f prime of x if f of x is equal to negative x squared plus 5x plus 2. Using the power rule will not get you any credit, but you should use it to double check your answer. So if I were to use power rule, I would expect that my answer would come out to negative 2x plus 5. So let's go ahead and see if that's going to be the case. I have f prime of x is equal to, I need to use the limit definition, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so if I plug in x plus h into my function, and then I want to subtract off the original function, and then this is all divided by h. So let's do some simplification. If I expand x plus h squared, that's going to be x squared plus 2xh plus h squared. I'm going to distribute this 5 here. And then I'm going to distribute my negative sign into these brackets. And then this is all over h. I'm going to go ahead and just distribute in this negative sign here as well. So that's going to be negative x squared minus 2xh minus h squared. And remember, when you're doing this process, likely in the numerator we're going to be left with things only that have an h in them. So 2 and minus 2 will cancel out, x squared minus x squared. And then this positive 5x and this minus 5x. And we do in fact have only things that have an h left over. So I'm going to go ahead and factor out h from this thing, and this term. And now what happens is these h's will divide out, and now I can use direct substitution. And so I have negative 2x minus 0 plus 5, and that will leave me with negative 2x plus 5, which matches what we forecasted at the beginning. So that completes question 3. Question 4 says, a kite 100 feet above the ground moves horizontally at a speed of 8 feet per second. At what rate in radians per second is the angle between the string and the horizontal changing when 200 feet of string has been let out? So let's draw a picture here. I have, let's say this is my person, and this is my kite, and then essentially this is forming a right triangle. And the kite is moving horizontally, so the kite's position is going this way at a speed of 8 feet per second. So if I'm labeling the distance between the person and the horizontal position of the kite, I can call that x. I know that the kite is moving horizontally, so its height from the ground is not changing, and it's staying the constant value of 100 feet. And then the amount of string that is being let out, that is changing. So the distance from the person to the kite is the length of the string. Let's call that c. And then the angle between the string and the horizontal, let's call that theta. So it says, at what rate in radians per second is the angle between the string and the horizontal changing? So our goal in this related rates question is to be able to find d theta dt. So in order to do that, we need to come up with an equation that we can use implicit differentiation on. And the equation that is going to be helpful here will be tangent of theta is equal to the opposite over the adjacent side length, so 100 over x. And I'm going to rewrite this as 100x to the negative 1 power so that it will be easier to take the derivative of. Okay, so now at this stage, we want to use implicit differentiation. I'm going to take the derivative of both sides of this with respect to t. And in doing so, the derivative of tangent of theta, that will give us secant squared theta. And then from the implicit differentiation, I'm going to need to multiply this by d theta dt. And then from here, I can factor out the 100 and then multiply this by the derivative with respect to x of x to the negative 1 power times dx dt. And the derivative of this using power rule is going to give us negative 1 over x squared. Now, again, our goal is to find d theta dt, so I could divide both sides by secant squared here. And remember that secant squared, if I'm dividing by that, I can bring it up to the numerator using one of the reciprocal identities. So we get d theta dt is equal to negative 100 over x squared times dx dt times, let's call this cosine squared theta now, since I divided both sides by secant squared. And so now we just want to come up with numerical values for all of these so we can get a final number. And dx dt, that is the 8 feet per second. So I have negative 100 over x squared. I'll figure out what that is in just a second. And then dx dt, that was the 8 feet per second. And then we also need to figure out what cosine of theta is. So let's draw a new right triangle. I have my theta here. There's that. This is 100 feet. And it says at the exact moment in time when 200 feet of string has been let out. So in that exact moment or snapshot moment, I have my hypotenuse length as 200. Let's call this x. And if I use the Pythagorean theorem, that's going to give me x squared plus 100 squared is equal to 200 squared. And if I solve this for x, I'm going to get x equals 100 times the square root of 3. So I'm just going to pop that in here. Okay, so then coming down here, let's replace this. I'm going to have 100 times the square root of 3, quantity squared. And then we also need cosine. So cosine of theta, whatever that is, I'm going to square that. So looking at my right triangle drawing, cosine is adjacent over hypotenuse. So that's going to be 100 times the square root of 3 over 200. Let's go ahead and simplify this. I have d theta dt is equal to... All right, so I went ahead and I've done some simplification, and I have 100 here and 100 here. This will change to a 1. And so this is equal to negative 1 over 100 times 3 is 300. And then if I multiplied that by 8, let's just move that over into the numerator. And then if I square the square root of 3 over 2, that's going to be 3/4. And then I can divide those, that will be 2. And then I can divide that, and that will be 100. And finally, we get negative 1 over 50. And we did expect, or we should have expected, that d theta dt would be a negative number because the angle is getting smaller as the kite moves more to the right. So we wanted a negative value, and then the units on this would be radians per second. And so here is our final answer for that question. Mr. Kwan decides to open up a boba shop to help fund his Pokemon addiction. Mr. Kwan finds that if he sells each cup of boba for $6, he sells 800 cups in a single day. If he raises the price of a cup of boba to $10, he sells 600 cups in a single day. Part A says find the demand function assuming it is linear. So I really like for these types of questions to make a table to help me create my linear function. So what is the independent variable and what is the dependent variable? So the independent variable is going to be the price of a cup of boba. And I'm going to call that or give that the variable x, and then our output variable or our dependent variable is going to be the number of cups sold, and let's call that f of x. So if I set my price for a cup of boba to $6, then 800 cups are going to be sold. So here I'll put 6, here I will put 800, and then for $10 I sell 600 cups. So what's happening here is we essentially have two ordered pairs that fall on our line. So I could call this one x1, y1, x2, y2, and if we're creating a linear function, we need the slope, and the slope is going to be y2 minus y1 over x2 minus x1, and so we have 600 minus 800 over 10 minus 6. That is going to equal negative 200 divided by 4, which ends up equaling negative 50. And a thing I could potentially ask you is, what are the units on this number? Because it is a rate of change. So our y values, these are the units of measure are number of cups, and then here, this is being measured in dollars. So if I'm writing the units for this, it would be cups per dollar. And what does this mean? Well, because this is a linear function and the slope is negative, it's essentially telling us it's related to the demand. And so anytime you increase the cup of boba by $1, you can expect to sell 50 cups less. Okay, so now that we have that information, we're trying to form f of x, our linear function. And we found that the slope was negative 50. And now we need to figure out the b value. Fortunately, we have two different ordered pairs we could use. And so I know that if I were to plug in 10, my output value would be 600. So this would be negative 50. And then I can add 50 to both sides. I definitely made an error here. That should have been 50, not negative 5 here. So let's fix that. That's going to be negative 500. And then if I add 500 to both sides, then we would get 1100. So my b value is 1100. And we find that f of x is equal to negative 50x plus 1100. And this is our demand function. Okay, part B says, suppose the cost to make each cup of boba is $2. Use calculus to figure out how much Mr. Kwan should sell each cup for in order to maximize profits. Okay, so a few things that we want to recall in order to do part B is we need the relationship that, and this is the mnemonic device I use, it's that people read negative comments. And what this really means is that profits are equal to revenue minus cost. And so right now we want to come up with the profit function, and in order to do that we need to come up with the revenue function and the cost function. So revenue, remember, revenue is how much money you are bringing in, and so revenue, which I will call R of X, is equal to the price of a cup of boba times the number of cups sold. And so earlier we defined the price of a cup of boba to be X, and then the number of cups sold was exactly our demand function. So I have negative 50X plus 1100, and so I can distribute in the X, and in doing so I get negative 50X squared plus 1100X. So that is my revenue function. Revenue is this thing here. Now I'd like to create my cost function, which I will call C of X. And earlier it said that each cup, it costs $2 to make. And so this would be cost of each cup times the number of cups sold. So in this case, each cup, it costs $2 to make, and then the number that we will sell is again given by the demand function. Okay, so I'm going to go ahead and distribute that 2 in. Okay, so I just want to kind of highlight my cost function is this thing here, which we simplified and found to be this. So putting this information together, my profit function, P of X, is equal to R of X minus C of X, which, let's go ahead and throw those in. I have negative 50X squared plus 1100X. And please be careful, we're subtracting off the cost function, so I would recommend brackets. Okay, so we get P of X is equal to negative 50X squared plus 1100X. And then if I distribute in that negative sign, I get plus 100X minus 2200. And the two middle terms are like terms, so let's combine those. And there we have our profit function. Okay, so now we need to take the first derivative of our profit function, and that will give us negative 100x plus 1200. From here, we can solve for our critical values by setting the first derivative equal to 0. And if I add 100x to both sides, I get 100x equals 1200, and then dividing both sides by 100. And the trick is we can cancel out the zeros there, and so we get x is equal to 12. And what do we want to do now? Well, this is our critical value, and we'd like to verify that this critical value gives us the type of local extrema that we desire. So I'm going to use the second derivative test, and we find that the p double prime of x is equal to negative 100. Now this is negative, which means that we have concave down, and when we're concave down, this gives us a local max, which is what we want because we are trying to maximize the profits. So going back and making sure that we're answering the question, it says use calculus to figure out how much Mr. Kwon should sell each cup for in order to maximize profits. And X, remember, is the variable that we use to represent the price of a cup of boba. So I just went ahead and wrote a sentence here. We have that a cup of boba should cost $12 in order to maximize profits. Okay, so part C, the last part of this question says, what would Mr. Kwon's maximum profits be? So if we know that this is our critical value X, and we want to figure out what the maximum profits are, we can plug in our critical value into our profit function. So I'm trying to evaluate P of 12. That is equal to negative 50 times 12 squared plus 1200 times 12 minus 2200. So I went ahead and I plugged that into this function right here. And if we throw that into a calculator, this ends up equaling 5,000. So if I wanted to write a sentence, let me scooch this over. We've calculated and we can say his max profits would be $5,000. And that concludes this question. All right, for this next question, we want to find the first derivatives of the following functions, and we do not need to simplify our answers. So for part A, I have f prime of x is equal to, I'm going to start off by using the power rule. And then I need to use chain rule by multiplying by the derivative of the inner function. And then plus this little portion right here is the same thing as cosine of 3x to the power of 1/2. So I need to start off by using the power rule. I'm going to decrease the power by 1. Then I need to multiply by the derivative of cosine of 3x. So the derivative of cosine is negative sine. And then I have an inner function from there, so the derivative of 3x is 3, so I need to multiply that by 3, and I'm just going to leave the answer like that because we are not required to simplify. Alright, so for part B, I have y prime is equal to, notice that I have one function here and one function here, and they're being multiplied. So the product rule tells me that I have the first function times the derivative of the second function. So it's going to be 1 over x squared. Then I need to use chain rule and take the derivative of the inside. So the derivative of x squared is 2x plus the second function times the derivative of the first function, which is an exponential function. And so we have 8 to the power of 3x minus 1, and then I need to multiply that by the natural log of 8. That's because the base is something other than e, or the natural log of e is also 1. And then from there I need to take the derivative of the inner function, or the exponent, which is 3. So here is my answer for part B. Alright, so for part C, I need to use quotient rule. So I have g prime of t is equal to the bottom function minus, no, not minus, the bottom function times the derivative of the top function. Let's see, so that's going to be 1 over 1 plus 5t quantity squared. And then I need to multiply by the derivative of the inside, which is 5. So that was bottom times the derivative of the top minus the top times the derivative of the bottom, which would be 9e to the power of 9t. And this is all over the bottom squared. Question 7 says, use the definition of continuity to determine whether or not the function h of x is continuous for all real numbers x. Explain. So if you look at this piecewise function that we have here, whenever x is not equal to 2, we have 3 plus sine of x minus 2 over x minus 2. And really, this thing is going to be, let me be more specific. This function here, as long as x is not equal to 2, that is going to be continuous everywhere else, because sine is continuous, and then its quotient, or the denominator, is x minus 2, and so the only really thing we have to worry about is when x is equal to 2. Fortunately, this function has a domain of all real numbers, so if x is equal to 2, our output value is 3, and so let's think about the definition of continuity then. So essentially we're saying all the numbers are in the domain. So this function h of x has a domain of all real numbers. Great. So then moving on to the second portion, or the second part of the definition of continuity, is that we have to say that the limit exists. And so, well, again, we really only need to be concerning ourselves with when x is equal to 2. So we're essentially trying to answer, does the limit as x approaches 2 of 3 plus sine of x minus 2 over x minus 2, we're asking, does this limit exist? And let's see, I can split this up into the limit as x approaches 2 of 3 plus the limit as x approaches 2 of sine of x minus 2 over x minus 2. And this thing here, because that's a constant, this is equal to 3, and I need to solve this second limit here. However, if I were to use direct substitution and plug in 2, sine of 2 minus 2 is sine of 0, so that's going to be 0, and then in the denominator I would also have 0, which means that I have the ability to use L'Hopital's rule. How do I want to write this? So this thing here, I'm going to solve this limit by using L'Hopital's rule. This is the limit as x approaches 2 of the derivative of sine of x minus 2 is cosine of x minus 2 over the derivative of x minus 2. That's just going to give me 1. And so now, let's see, I can use direct substitution, and that would give me cosine of 2 minus 2, which is equal to cosine of 0, which is equal to 1. So this thing here is equal to 1, and we find that this is equal to 4. Okay, so we've kind of satisfied the first two conditions in the definition of continuity. We've said that the function essentially, it has a domain of all real numbers, and then the limit as x approaches 2 exists. So let's kind of synthesize all of this information. The limit as x approaches 2 of h of x exists, and it equals 4. Now, the third condition, in order to be continuous at x equals 2, because again, we know that it's continuous everywhere else, but in order for this to be continuous at x equals 2, we must have the case that the limit as x approaches 2 of h of x must equal h of 2. However, h of 2, from what we can see here, h of 2 is equal to 3, and then the limit we just found was 4, and these are certainly not equal to each other. So because those are not equal to each other, we can say that h of x is not continuous at x equals 2. It is continuous everywhere else. So it turns out that there is a removable discontinuity at x equals 2. So let's write that. There is a removable discontinuity at x equals 2. And that's it for this question. The last question, part 8, or question 8, says indicate whether each statement is true or false by shading in the circled capital letter. Each question is worth 2 points, and you don't need to show your work on this question, and you don't need to justify your answer. However, I am going to justify your answer. So part A is, or says, if h of x is equal to f composed of g of x, then h prime of x is equal to f prime of g of x times g prime of x. This is in fact true, and this is basically just a restatement of the chain rule. Part B says if m prime of x has the following graph, then m of x is increasing on the interval from negative infinity to 0, union 0 to infinity. This one's a bit of a tricky one because really this is a parabola and it goes to the origin. So we could certainly say something like here, the graph of this, the graph of this thing is like y equals x squared. And so if I took the antiderivative of it, let's say m prime of x is equal to x squared. If I took the antiderivative, we'd have m of x is equal to x cubed over 3. And so I'm just going to plot it on here. X cubed is going to look something like that. If we divide by 3, then it, that is a vertical compression. However, we still essentially have the cubic graph function, and this is increasing everywhere. So m of x is increasing on the interval negative infinity to positive infinity. So this is false. And the last one is, I included this on here because students often make this error. You cannot use the power rule on this. This is an exponential function. Cannot use power rule on it. So this is false. Please do not use power rule on this thing. All right, that concludes this video. Thanks for watching.